In the fast-paced world of software development, testing plays a pivotal role. It ensures that the software we use is reliable, efficient, and meets the needs of its users. As a result, the demand for skilled testers, both manual and automation, continues to rise. Acing a testing interview requires more than just technical knowledge. It demands a clear understanding of testing principles, methodologies, and the ability to articulate your thoughts effectively. Preparation is key. This essay aims to equip aspiring testers with the knowledge and confidence to excel in their interviews. We will delve into common manual and automation testing interview questions, providing clear explanations and practical examples. Remember, the goal is not just to provide answers, but to foster a deeper understanding of the concepts. Manual testing is a crucial part of software development. It involves human testers meticulously checking every aspect of a software application without the use of automation tools. One of the first things to understand is the difference between functional and non-functional testing. Functional testing verifies that the software behaves as expected based on the requirements. For instance, if you're testing an e-commerce website, functional testing would involve checking if users can add items to their cart, proceed to checkout, and make payments successfully. Non-functional testing, on the other hand, focuses on the software's performance, security, usability, and other aspects that are not directly related to its functionality. This includes things like load testing, security testing, and usability testing. Understanding this distinction is fundamental for any tester. It helps in designing effective test cases and ensures comprehensive test coverage. Test plans and test strategies are essential documents in the software testing lifecycle. While often used interchangeably, they serve distinct purposes. A test plan is a detailed document outlining the scope, approach, resources, and schedule of testing activities. It's a comprehensive guide for the entire testing process. A test strategy, on the other hand, is a high-level document that outlines the overall approach to testing. It defines the testing types to be performed, the testing environment, and the tools to be used. Think of the test strategy as the blueprint for the testing process. It defines the what and why of testing. The test plan, on the other hand, is the detailed roadmap that outlines the how, when, and who of testing. Both documents are crucial for successful testing. They ensure that testing is systematic, well-organized, and aligned with the project goals. Acceptance testing is the final stage of software testing. It's performed to determine if the software is ready for release. This type of testing is usually done by the end users or stakeholders to validate if the software meets their business requirements and expectations. Traceability, in the context of testing, refers to the ability to track every requirement to its corresponding test cases and vice versa. This ensures that all requirements are tested and that any defects can be traced back to their source. The traceability matrix is a document that maps test cases to requirements. It provides a clear view of the test coverage and helps in identifying any gaps in testing. This matrix is crucial for ensuring that the software is thoroughly tested and that any issues can be easily tracked and resolved. Smoke testing and exploratory testing are two distinct testing approaches used in different scenarios. Smoke testing, also known as build verification testing, is a quick and superficial testing technique performed to determine if a new build is stable enough for further testing. It's like a quick health check of the software to catch any major issues early on. Exploratory testing, on the other hand, is a more free-form approach where testers don't follow predefined test scripts. Instead, they rely on their knowledge, intuition, and experience to explore the software, discover bugs, and learn about its behavior. Think of smoke testing as a quick checkup at the doctor's office to ensure everything is functioning as expected. Exploratory testing is like taking your car for a spin on an unfamiliar road, exploring different paths, and uncovering potential issues along the way. Ad hoc testing and negative testing are two testing approaches that focus on uncovering unexpected issues by deviating from the norm. Ad hoc testing is an unstructured and informal testing approach where testers aim to break the software by trying different scenarios without predefined test cases. It's a spontaneous and improvised approach that relies on the tester's creativity and intuition. Negative testing, on the other hand, focuses on testing how the software handles invalid or unexpected inputs. The goal is to ensure that the software doesn't crash or behave erratically when faced with incorrect data. Imagine ad hoc testing as randomly pressing buttons on a remote control to see what happens. Negative testing is like deliberately entering incorrect data into a form to see how the system responds. Both testing types are valuable for identifying potential weaknesses and vulnerabilities that might be missed by more formal testing methods. Localization testing, catering to a global audience. In today's interconnected world, software is often used by people from different countries and cultures. This necessitates localization testing, a specialized type of testing that ensures the software is adapted to meet the linguistic, cultural, and technical requirements of a specific target market. Localization testing goes beyond simple translation. It involves adapting the software's user interface, date and time formats, currency, and other elements to align with the local conventions of the target region. For example, a website localized for France would display content in French, use the euro currency, and follow French date and time formats. Effective localization testing ensures that the software is culturally appropriate and accessible to users in different regions, enhancing user experience and satisfaction. Navigating the world of automation testing with Selenium Java. Automation testing has become an indispensable part of software development. It involves using specialized tools to automate the execution of test cases, improving efficiency and test coverage. Selenium, with its support for Java, is a powerful open-source framework widely used for automating web applications. Selenium allows testers to write scripts in Java to interact with web elements, simulate user actions like clicking buttons and filling forms, and verify the application's behavior. Its versatility and compatibility with various browsers make it a popular choice for automation testing. The combination of Selenium and Java provides testers with a robust and flexible framework for automating web application testing. It enables them to create reusable and maintainable test scripts, improving the speed and accuracy of the testing process. Handling browser-specific actions and cross-browser compatibility. When testing web applications, it's crucial to ensure they function correctly across different web browsers. Selenium, thankfully, excels in this area. Cross-browser testing involves verifying that the web application works as expected across multiple browsers like Chrome, Firefox, Safari, and Edge. Selenium WebDriver, a key component of Selenium, provides a consistent API for interacting with different browsers. This means that testers can write test scripts once and execute them across multiple browsers, reducing redundancy and saving time. To ensure consistency across different browsers, Selenium allows testers to handle browser-specific actions. For example, you can write code to handle browser alerts, manage browser windows, and interact with browser-specific features. By leveraging Selenium's cross-browser testing capabilities and its ability to handle browser-specific actions, testers can ensure a consistent and reliable user experience across all major web browsers. Advanced Selenium techniques, timeouts, waits, and desired capabilities. Web applications are dynamic, and elements may take time to load. This is where Selenium's advanced features like timeouts, waits, and desired capabilities come into play. Timeouts in Selenium define the maximum time the WebDriver will wait for a particular action to complete before throwing an exception. Implicit waits, for instance, instruct the WebDriver to wait for a specified time for an element to become available before interacting with it. Explicit waits, on the other hand, allow testers to define specific conditions to wait for, such as an element to be clickable or a particular text to appear on the page. Fluent wait is a more flexible type of explicit wait that allows you to specify the frequency of checks and handle exceptions more gracefully. Desired capabilities are a set of key value pairs used to specify browser preferences, operating system details, or other browser-specific settings when launching a browser instance. They provide fine-grained control over the browser environment, enabling testers to configure it according to the test requirements. These advanced Selenium techniques provide testers with the tools and flexibility to handle dynamic web elements, manage browser interactions effectively, and create robust and reliable automated tests.